Hey guys, one of the most common ways that you can make amines is through the reduction of more highly oxidized nitrogen compounds. There's actually a ton of these reactions. So what I'm doing in this video is I'm grouping together a bunch of similar reductions that all generate primary amines so that you can have like a cheat sheet of similar related reductions that all lead to the same type of product. Now, as a disclaimer, keep in mind that your professor may not need you to know all of these right now. But I'm banking on the fact that at some point in this course, you're going to see all these reactions in different places. So I'm grouping them together for you so that you'll think of them as similar reactions that are related to each other, okay? So let's start off with amines by reduction. So as you can see, I've got a lot of arrows here. There's 6 main reductions that we're going to consider to be related. They all lead to the same product, which is a primary amine, okay? Now, before we get into the specific reactions, I want to talk about something I'm calling the common reducing agents. Now, this is not a term you're going to see in your textbook, but just through, kind of looking at all these reactions, I noticed that there are some reducing agents that are used more often than others. And the ones that are the most common are lithium aluminum hydride, which is your typical strong reducing agent. H2 and palladium catalysts. That would just be catalytic hydrogenation. Obviously, you could also use nickel or platinum for that. And then finally, iron and HCl, which is also pretty commonly used, okay? I'm going to refer to these as the common reducing agents, and I'm just going to generalize them as H in brackets. Now, H in brackets always just stands for reduction in general. So I'm just going to say if I write an H in brackets, that means all 3 of these reactions count as a reduction that would work here, okay? So let's go ahead and start off on the left side of my chart, and then we'll kind of move to the right side. And what we're going to find is that the first few reagents are just straight common reducing agents all the way. So if you want to turn an amide into a primary amine, guess which reagents you use? You're going to use your common reducing agents. So that means you could use lithium aluminum hydride, you could use catalytic hydrogenation, you could use iron and HCl. It's up to you. All of them work, okay? Pretty easy so far. Let's move on to the next one. Nitrile. How about if I want to turn a nitrile to a primary amine? The common reducing agents. Awesome. So once again, it's the same 3 reagents. The same 3 reagents can work with a nitrile to add hydrogens to that triple bond. By the way, it is going to be 2 equivalents. That is kind of interesting. So that means whatever you're reacting with is going to work twice since there's a triple bond. You have to get rid of both of those pi bonds, and you wind up getting your primary amine. Bueno. Okay, let's keep going. So what do you guys think about nitro groups? A nitro group can turn into a primary amine using the common reducing agents. Awesome. Okay, so this chart is seeming pretty easy actually because we're using the same reagents for all of these. You can use, again, the 3 reagents that we talked about would all work. But actually nitro is special, guys, because I have discussed this in the past. I do have other videos talking about the reduction of nitro groups. And maybe you guys might recall, or maybe you haven't heard of yet, that there's a chemoselective reducing agent that really just focuses in on the nitro group and doesn't reduce any groups around it, okay? Maybe you guys remember it, maybe you don't. I'm going to write here, which one's the chemoselective one? Well, it turns out that there's another reducing agent that you can use on nitro that is probably the ideal one to use, and that's what we call tin 2 chloride. It's SnCl2 and water, okay? This is also known as, I'm just going to write it in a different color. This is also known as stannous chloride. Okay? Stannous chloride or tin 2 chloride. Whatever, they're all different ways of saying it. But anyway, stannous chloride, tin 2 chloride, SnCl2 over water. What that's going to do is it's a very special reagent because it only works on nitro groups. It doesn't reduce anything else, which means that we don't have to worry about protecting other vulnerable groups to reduction. It's only going to react with NO2, which is why we call it chemoselective. Awesome. So let's move on to the other side. So guys, the other side is going to get more complicated as a heads up. Okay? So if I want to turn an azide is a functional group with N, double bond N, double bond N. Okay? It's got some formal charges in there, but they balance out, so there's no net charge, okay? Now for azide, we're not going to be able to use the common reducing agents. We're going to use another reagent instead, and that is a triphenylphosphine. So PH3P and water. Okay? And what this is going to do is it's going to work consecutively on those nitrogens to basically it's going to release two of them, and you're going to just get a primary amine. Okay? So what about the next one? Well, I have a question for you. Maybe you guys can integrate some other stuff we've talked about before. What do you think about my common reducing agents here? If I took carbonyl, in this case, this is an aldehyde, right? So if I took an aldehyde and I used one of the three common reducing agents on this, would I get an amine? What do you think? No, guys. If you use, for example, lithium aluminum hydride, LAH, if you use that on my aldehyde, you're going to get an alcohol. You're not going to get an amine. So how do I turn a carbonyl without a nitrogen group on it? How do I turn that into a primary amine? Well, guys, for this, you can only use one solution, one of my favorite reactions. This is going to be reductive amination. Reductive amination is going to turn a carbonyl into a primary amine. So the reagents for reductive amination are going to be some source of nitrogen. So I'm just going to put NH3, but it could be any source of nitrogen that's either a methyl, not methyl, a 0 degree or primary degree. Some kind of acid. So I'm just going to put here H+. So it's always going to be in an acidic environment. And then you're going to use, in the second step, you're going to use a reducing agent that has a cyano group in it. So it's NaBH3CN. Okay? So what you wind up doing is, in the first part, it's going to be kind of like an amine reaction, like making an imine. And the second part is a reduction that takes that imine and makes it into a carbonyl. Now, guys, I do have separate videos for some of these reactions. So, for example, reductive amination, if you want to know more about the mechanism, you can just type in reductive amination into the search bar, and then you'll find a whole video just about that one reaction. Remember, this is just a cheat sheet, so I'm not going to really go through any mechanisms on this sheet. Okay? Now, so hopefully, you know, that one makes sense. You guys know you need to learn that one. What else? How about if I want to turn an acyl azide into a primary amine? Well, guys, this one's a little bit more complicated. Again, we're not going to use the typical common reducing agents. This is going to be a very famous reaction called the Curtius rearrangement. Okay? Again, very important reaction. You may need to know it now. You may not need to know it now. But there is a separate, a whole separate lesson just on this one reaction. It's a very strange mechanism. And the reagents for a Curtius rearrangement are just going to be two things. It's just going to be heat and water. Pretty straightforward, okay? So heat and water, as you can see, it's like, how does this thing turn into a primary amine? Well, eventually what winds up happening, guys, is that you've got your R group here. So that's your R, okay? And you've got your nitrogen here. And eventually you wind up making a bond between those two. So I know I was kind of in the way for that, but what I'm trying to say is that these two carbons here wind up attaching to the one single nitrogen that remains here, and you wind up getting, there you go, your primary amine, because you got your two carbons. It could have been as many carbons as I wanted, but on this structure it's 2 plus the nitrogen gives us our primary amine. Again, not going over mechanisms here, but you could search the Curtius rearrangement and then I'll explain that whole reaction in detail. Alright, so now we're done with all of the amines by reduction. These are all the reactions that I consider similar because they all yield the same exact product, okay? Now what I'm going to do is, in the next video, I'm going to talk about some related reactions that might help us make the initial starting product. So let's move on to the next video.